In this video, we're going to look at something that you've seen before, but we're going to put a formal definition on it, and that is what it means to be an interval. So we already have an intuitive understanding of what an interval is. We'll talk about that. We'll talk about the need for an operational definition, and then we'll give a precise definition of intervals. And finally, we'll take a particular set of real numbers and we'll prove it's an interval. And just note that even though it seems a little weird to be looking at this now, it's going to be helpful for understanding some of the real number concepts that we're going to look at in the next couple of videos. Later. So let's look at the two sets, 6, 9 and 1, 2, union 3, 4. It's clear by looking at them that one of those is an interval and one of those is not. 6, 9, that looks like an interval. Though 1, 2, union 3, 4, that is not an interval. But we can't just say it's interval or not an interval just by looking at it. We got to have an actual definition. So let's first look at why the second one is not an interval, right? Why is the union of 1, 2, and 3, 4 not an interval? Well, basically, there's a gap between 2 and 3. And so the question you might ask is, okay, how do we formally detect that gap? Well, if you took an element in 1, 2 and an element in 3, 4, there are some numbers between them that's not in the set. And so if you have a definition to eliminate that possibility, that gives us the definition of an interval. So an interval is a set I contained in R that has, first of all, at least two elements. We don't consider a one real number set to be an interval, such that anytime you have x and y in the interval, z a real number with z between x and y, then z is also in that interval. And so that eliminates the possibility that you could have two elements in the interval and a real number between them that is not in the interval. So the way we would prove then, using that definition that 1, 2, union 3, 4 is not an interval, is we take 1.5, which is in the interval, 3.5, which is also in the interval, and then we take 2.5 in between those, and note that, well, 2.5 is not in the interval because it's not between 1 and 2, not between 3 and 4, and that means it's not an interval. But 6, 9 is an interval. Now, to prove this one, we can't just look at one example. We have to prove a for all statement. So we have to set up our assume and our show. So remember that 6, 9 is the set of all numbers x between 6 and 9, not equal to 6, not equal to 9, but between those two numbers. So we'll assume that x and y are in the interval 6, 9. We'll assume that z is a real number. We won't assume it's in the interval. We'll assume it's any real number that's between x and y. And we want to show that z is in 6, 9. So we want to prove that z is greater than 6 and less than 9. So first of all, since x is in the interval 6, 9, we know that 6 is less than x. We also know by assumption that x is less than z, and this is a perfect setup for the transitive property. Since 6 is less than x and x is less than z, that tells us that 6 is less than z. So we proved half of the inequality that we want to show. For the other part, we'll note that z is less than y. That's by assumption. We're assuming that z is between x and y. We know y is less than 9 because it's in the interval 6, 9. And again, using the transitive property, we prove that z is less than 9. We now know that z is greater than 6 and less than 9. And that means that z is in 6, 9, which proves that 6, 9 is an interval. So now this should get you set up for working on the activities for the intervals. Just look at the link below this video.